Okay, I want to just make one change to this previous primes function and do a new one. So I I like consistency, and like when I'm looking at this output here, I actually like that. But I look up at the alternatives, just yes, we could do a little better, right? Like let the user know that we're getting it right. Like yes, just do an F string. Simply yes, number is prime, right? That provides more clarity. And same thing here. We could say no, um, number F string again. Now if I'm gonna do a comma up here, I should do it down here. What do you think? Comma, no comma. Tough call. I think it should have a comma because it's like a pause. Yes, it's like a different clause. So yes, or in this case, no, number is not prime. Right? Then we're providing a lot more info. Okay, so that was done in the previous video. I actually want to move on and do the big one. I use this to separate really two levels of coding. And I would say it's actually advanced maybe is the separation. And here's it also requires knowing math, but generate prime numbers. And when I say that, how about this? What does he mean? Like say a list of prime numbers. And then be more specific about less than or equal to a given number. And so the idea is to write code to do this. Like for instance, can we write code to have all the primes less than or equal to 1,000? Okay, that's tough. It's tough. And here's what I can tell you. If you cannot come up with the algorithm, okay, to do this, you're not going to be able to code it. It's back to the pseudocode idea. It's a big idea in coding. You need to come up with the plan first, right? Like how do you do it? And I think the way to do it is to honestly do it, okay? Pretend like you don't know. Let's do all the primes less than 100, but we have to generate them, okay? So we got to start somewhere. I'm going to do this in a text cell. Okay, where do we start? Let's just start with like 2, okay? 2 is, there's the list of prime numbers, okay? We're starting with 2. Now we check 3. Okay, so this is like our starting place. We got to start somewhere. B check 3. Is it prime? Right, remember you need that double. I'm just looking at the right and left here. Double return makes it look better. And you can have steps. These do have numbers, by the way, like if instead of A and B. So if I highlight this, if you look over some of these options, right, you see the numbering. You know, looks a little better, I think, because since we're going to be doing multiples of these, so start with 2, and then we're checking is 3 prime. And here's my point. How do we use the list, which is only 2, to check if 3 is prime? Well, 2 doesn't go into it. That's all we have is 2. Yes, because 2 does not go into it. Right? So this is really important because we're checking the elements in the list. So not only do we check 3, we now include it because we now have 2 and 3, right? And now we get to 4. Okay, so it's also number 4. So check 4. Is 4 prime? Well, no, because we start with the list and 2 doesn't go into it. I mean, 2 does go into it, right? No, because 2 divides it. Okay, do one more. Now we just check the next number. Check 5. Is 5 prime? Well, we've got to check. Does 2 go into it? No. Does 3 go into it? No. Do we need to check 4? No. we only need to check the primes. Okay? So is 5 prime? Yes, because 2 and 3, both, we loop through the whole list, because 2 and 3 do not go into it. And so then we get 2, 3, and 5. And then this continues, okay? So this is like an algorithm, okay? This algorithm, I've just been writing it kind of out in these little steps, will work. Let me press Shift Enter to get it there, Okay, so let's try to go ahead and code this, okay? And we'll wait on some shortcuts to speed it up. Let's just first try it like this. All right, so how do we start it? Well, look at our pseudocode. Let's start with 2. We got to start with the list of primes. Primes equal 2. Let's go ahead and say that we're in a function here, because it's less than or equal to a given number. So def prime generator. Oh, this is really cool. Like a prime generator. And I'm going to tell you why. Because now that we have computer programming, you can write code to actually do this. If you go back like 500 years ago, people didn't have computers. So when you got to gargantuan numbers, like numbers over 10,000, it would have been really hard to determine if they were prime, because people had to do this stuff by hand before there were calculators. So nowadays, code's really powerful, computers are powerful. You can get a lot of these, and it's fun to always look up like how many primes are known, what's the biggest known prime. I encourage you guys to check that stuff out. Okay, so this is like the max number, right? Like, because you can't, why does there have to be a max number? Because there's an infinite number, okay? You can't actually get them all. The code would go on forever. So you got to stop somewhere. All right, so we start with primes is equal to 2. Now, we're checking 3. How do we check 3? Okay, what are we checking? Well, we're starting and note that in the code underneath, we check 4, we check 5, and again, when do we stop? We stop at max number. So we're looping through a bunch of numbers. Do you know the right Python code to do that? I want to start at 2, end at max number, and check every one. For loop. For I in range, start with 3 actually. But I said less than or equal to, so we want to go to max number plus 1, right? Because the range will not include the last number. Okay, so now I is the number. Cool. So how do I check if 3 is prime? I've got to go through the whole list. Why do I say the whole list? I mean, say, hey, it's only 2. Well, we just did the practice. If you look down at 5 and you check it, you've got to go through each of the numbers. So to do the check, we're checking if basically is I prime. So we've got to check for the prime numbers that are in the primes list, okay? In this case, it's just 2. We are checking to see if what? What's the connection with I and prime? It's the question. Well, it's helpful to actually look at the case where it's not like the fourth one, number 4. That's a no. Why? Because the bigger number, which in this case would be I, mod prime, is equivalent to 0. Okay, that's what we are checking. Okay, if I mod prime is equivalent to 0, it is not prime. Right? That's what we get with number 4. So when is it prime? Well, if you go through each of these, okay, each of the primes, like in number 5, and that doesn't happen. Okay, so if it doesn't happen, you end up right here. okay? And if you end up right there, it's prime, okay? It's a little tricky with the indentation. Let me say that again. When you loop through each of these, okay, you're in a loop here. You're just checking, hey, do the prime numbers go into it? If so, I think we should probably do something. But what I want to do is actually, you don't add it, okay? And what you can do, you can just write break. And what that does, that's a keyword, you break out of the loop that you are in, which is this one. It should only break that loop, not the one above it. Okay? But if that doesn't happen, you're going to end up eventually here. And then you add it to the list. It made it through. Imagine it's like an obstacle course here. And if you divide it, boom, you're down, broken. If you make it all the way through, you make it to this line and you are a prime. So then what you do, you want to add it to the list. So primes dot append, and then what is our prime number here? I think it's I, right? Because we're adding it to the list. It's not yet prime. Okay. Will that do it? I don't know. Let's try it. Let's run this and see what happens. I honestly am not sure, right? I think it's coded about right, but again, about and exact are a little different. So press Shift Enter to run it. I'm going to get a coding cell underneath. And prime generator. And let's not do too many. Let's just do all the primes under 10. 10 is the max number. Oh, I didn't return anything. I want to return the list of primes. So again, you've got to line it up properly, right? Because if I put it here, okay, do you see where the cursor is? It's going to just return the first number. You've got to get to the return at the function is done. You've got to get to the far left, backspace. Return here. Return primes. Okay, Shift Enter. Let's give it a whirl, okay? What do you think? Maybe you can see an error, or something needs to be added or fixed. Go ahead and do that. Otherwise, I'm going to give it a whirl. See, it didn't work, right? It got all the numbers, so that's not what we want. So let's look at this. Okay, coding the primes are tricky, I can tell you. Did break not work? See, because my understanding, if it breaks, maybe I put this in the wrong place here. Yeah. Let me know if well, we're not live yet. If anybody has a quick fix, I would say let me know, because my students are bright and good at doing this. So it's not quite right, but as the general idea, it has to do with the breaking. Like when we break out of this for loop, it's coming here. That's the problem. Because it's not in the right place. Shoot. Okay, so see, you might think, well, what about an else? Well, the problem with the else is that it's actually got to make it through each one. Okay, so here's a way to fix this. I'm going to use a Boolean. These Booleans can be fun. So when we check a number, like we're right here. Okay, we check one number, like 4. And we can even use this idea is prime as a variable here equals, we've got to pick, we can change it, like should it be true or false? Let's say false. No, I think we want it to be, see, instead of break, what we could do is say, if that's the case, well, before we break the loop, you can still break it, can save time. We can set is prime equal to false. And then if that doesn't happen, it is true. Okay, so we start off, hey, let's just assume it's prime, but we change it here, and then at the very end, when we get down here, we only make the change if is prime is true. then we append it. You see how that works? So this is where Booleans can be really advantageous. We're just going to assume it's prime. But hey, once we get that divisor, like in this case 4, we'll do that, right? We'll get that. We switch it to false. Then it's going to break and come down here, and it's not going to append it, okay? Because it's false, right? And if we always do those checks and you never get it, it never gets changed. So then when you come down here, it is prime, it's true, and then you can go ahead and append it. Okay, let's see if that works. Press Shift Enter, prime generator. Bam! We got it. It's hard to do. What can I say? Okay, let's. We got it under 10, but that's right. It should work then under 100. Look at that. See, this is where coding is just beautiful, right? Oh man, beautiful. Can we do 1,000? What do you think? Can Python handle it? Or my code? I think the code can be improved. It does it pretty quickly. Look at this, because like I don't know if 709 is prime. It looks right because it's not doing like every number. Cool. What I want to do now is one more thing to actually improve this. It has to do with the check. Okay. So let's go back to 10, right? Well, actually, let's do 100. I want to do 100. I'm going to go back, change this to 100. Okay, so look at this. Here are the primes less than 100. Now, let's just jump at the end here. So let's say, we're at 97 and we're checking to see if 97 is prime. Well, you're going to check if all the other numbers divide it. Look, if you go up here to 47, 47 times what would be 97? If you're at 2, it would be like 94, but you already checked 2. Okay? So it's not even just halfway. It's pretty amazing. Look at the number 10. What's 10 times 10? It's 100, right? Once you hit 11, okay, you're checking 11, is 11 prime. It has to be 11 times a number less than 10. Okay? Does that make sense? Right? 11 times 9 is close. It can't, because if you go higher than 11, it's too big. So what's the connection with 10 and 100? It's the square root. You don't have to check beyond the square root. Okay? So this for I in range doesn't need to be this. It's the square root. So how do we get the square root? It's the max number to the, wait a minute, is that where it goes? Wait, these are the numbers that we're checking. Like where are the primes that we're checking? Because we actually want to check if 97 is prime, so I think that's not where it goes. We want to do the square root. It's like when we're checking, we're looping through the primes. Here it is. That's for the prime and the primes. So we don't need to go through and check every one of them, okay? Because when they're small, you want to, but when they're big, you get a big list. You don't need to do that. And I think for the sake of time, I'm not going to try to add that in right now. I will leave that to you all as an additional challenge. Like, can you find a way to code this to make it more efficient so that it doesn't actually loop through all the primes? Okay. And furthermore, there are a lot of fun prime challenges you can do. You could use this idea to potentially make this previous code that we wrote more efficient to determine if a number is prime. Why? Because if you're getting with gargantuan numbers, like, you don't need to be checking if non-primes divide into it. You just need to check the primes. So you can potentially generate the primes to do that. Okay, but I'll stop this one now because it's a long video. But that's a prime generator, and that in itself is awesome.